Now let's look at the next data set. So this was the salary data for city government positions in California. So let's go ahead and add a cell after this. Actually, I'm going to go ahead and um, open the connection to the SQLite database and execute a fetch all, and then read all the data from the salaries table and display it. And then after that, I'm going to go ahead and add another cell, and then I'm going to explore this data frame. So this is a little bit more complicated than the name data. The salaries table has ID, and actually just looking at this, we see that all these values all have 148,654 non-null values. So it looks like there are no null values in this table. But this doesn't actually mean that there are values supplied for each field, because if you look at the actual data, you say there's the string not provided. So not provided really means the same thing as null, essentially. And that's just how this particular data set has decided to mark that off. So if we wanted to maybe convert these to null values instead of not provided, we could do that. And then we may also want to filter out the rows where some of these values are not provided. So we have ID, employee name, job title, base pay, overtime pay. Notice that these are all objects instead of numbers. And if you look at the value for base pay, for example, you'll see most of these are numbers, but then it's not actually numeric because some of them are the strings not provided. So Pandas is confused about the type because sometimes it's a number and sometimes it's a string, but really sometimes it's a number and sometimes it's a null value. So that might be something that we want to fix when we're cleaning the data as well. And then there are a bunch of different pay columns. There's a benefits column, total pay, total benefits. Then there's a year, which Pandas has successfully recognized as an integer value this time. There are some notes, which is probably a string, agency, which is a string, and status, which is a string. And we can look at those actual values here. So agency is the city, San Francisco. Let's actually look at the number of unique values. So here, basically each ID is distinct for each row. Mostly employee name is distinct, but there are some duplicates, 30 some odd thousand duplicate names. There are only 21 or 2,000 distinct job titles, so that might actually be an interesting thing to look at, is which job titles have the highest total pay. That might be something that I would want to ask with this data set. Or I might want to look at what job titles have the most employees. So that would be a different way of ordering it. In either case, I might want to look at, say, the top 20 most highly paid job titles or the top 20 positions that had the most employees. And then let's see what we have a distribution of various pay. For year, we see that only 4 years are covered. So maybe we want to break that down by year for 4 years. There's only one value for note, one value for agency, so this is only San Francisco data, and then 3 values for status. And can actually look at the specific values. So we see ID is just a number, employee names, job titles, and then a bunch of pay values. So the years cover 2011 through 2014, so there might be something we want to do with that. Agency is always San Francisco. None of the notes columns have anything useful in them. They're all empty. And then status is part-time or full-time or unmarked. So this might also be a way of splitting the data up. So we might want to compare part-time pay to full-time pay, part-time benefits to full-time benefits, and so on. So there's a couple of interesting ways that we can slice and dice this data. But the main cleaning that we're going to want to do is to get rid of these not provided values and then probably either filter in or filter out rows where those weren't provided.